At UVA, we're really focused on research that exists at the intersections of traditional disciplines. This is where some of the most challenging and exciting problems exist. We are creating an infrastructure and a community at UVA which really allows faculty from many different disciplines to work together in ways often not possible within academia. And this enables us to make significant advances in these technical areas that are most challenging and most relevant for society.
UVA is one of 3 sites that are pursuing this area of multifunctional integration of systems technology, and that's the MIST Center. The MIST is basically what is called a Industry University Cooperative Research Center, IUCRC. In short, it's an opportunity for industry, academia, and government to come together, define certain areas of strategic interest, and pursue what is called pre-competitive research, which means research that's not quite fundamental, but it's not yet ready for commercialization. Today, electronics is going through some changes. We are in what is called the post-Moore's Law era, where the kind of Moore's Law is ending or slowing down, depending on who you ask. And so there's a lot of emphasis around the industry to try and figure out what comes next, whether it's better architecture, better materials, and how to integrate them. So the focus of the MIST Center is to develop the hardware basis for this Internet of Things. In other words, it couples new materials that are coming out from material science with new kinds of architecture that are developing in computer science. And our job is to kind of bridge the two.
So MMI, which is just an abbreviation for multifunctional materials integration. And the core purpose is to find ways to integrate across length scales and to integrate across functionality from really the atom to the finished device and architecture. MIST and MMI both kind of really rely on the question, how do you make the best possible materials to achieve your goals? So in a way you can think about MMI as well as some parts of MIST like the physical part of the Internet of Things.
The thrusts of MIST are integration, computing, sensing, wireless, and power. We have several core projects within MIST at UVA that are focused on optimizing processes, design, and understanding fundamental characteristics of materials anywhere from the atom to the application. Some of our core projects involve developing higher frequency, higher power photodiodes, developing higher power amplifiers for links, reconfiguring antennas for wireless platforms, or in my case, tuning thermal resistances at atomic scale interfaces. In the UVA site of MIST, we have a world-class cleanroom facility for device fabrication and a brand new renovated material growth and characterization facility. We can grow materials and translate them directly into devices, all in one fell swoop at UVA.
This is the UVA microfabrication facility for the investigation of electronic, photonic, thermal, and magnetic materials, circuits, and devices. The research in this facility ranges from devices for radio astronomy around the world, looking out at galaxies and the stars, how the universe is formed, to microfluidics for medicine and diabetes treatment, to photonics for long-range communications.
In the nanoscale materials characterization facility, or the NMCF as we call it because it's a mouthful, we basically use light, electrons, ions, and X-rays to understand the structure and the chemistry of materials. And so we have about a dozen different tools in this facility that we use to see things from the macroscopic level all the way down to the atomic level, and even to understand the states of the electrons around particular atoms and how those produce properties of materials.
When we work with industry, and when we work with our industry partners, we are performing research with their guidance that can see translation of our results immediately to the next 5 or 10 years.
Part of the beauty of the MIST Center's IUCRC model is that it really allows companies to have full control over the research being done in the MIST Center. That's great for faculty as well as for industry because it provides really clear vision. It helps take technology from concept to market. We focus on fundamental technologies, so not stuff that's quite ready to go to market yet, But this allows companies to explore many different ideas in a way that reduces overhead dramatically. So while it might cost a significant amount of money to spin up an idea internally at an organization, bringing that technology to the MIST Center helps explore ideas very quickly and very cost efficiently.
The interaction that the UVA faculty and students have with industry members is incredibly unique. To be able to work with industry and see the translation of our research into technology or into something that industry is incredibly excited about is an opportunity that students can really rally around and that we faculty don't have often.